Assalamualaikum and greetings to all panels and everyone who watched this video. I hope you guys is in good condition. My name is Muhammad Danial Hakim bin MUHYIN from semester 8 of Faculty of Mechanical Engineering. Today, I will be presenting on the investigation on weld nugget and heat affected zone development of spot welded DP600 by 3D simulation. My presentation divided into 4 parts, which is the introduction, which explain the background study of resistance spot welding, the methodology of the setup of the experiments, the analysis of the weld nugget form and the heat affected zone. Next one is the conclusion, which summarize the whole studies and the future improvement that can be made. The introduction of resistance spot welding. It is a process of joining two metal sheets which commonly used in our automotive industry. The advantages of resistance spot welding is it is fast, well maintained, and easily automated. Other advantages are low cost, efficient, safe due to no sparks created, joint is strong, and no special personnel required to operate. The important parts of using resistance spot welding is the selection of the material used and the design of the product. The objective of the study is to study the characteristic changes at the non-melted area due to excessive heat. The second one is to study the structure of material DP600 when few elements were added. The third one is to study the weld nugget and heat affected zone by MSc simulation. The work scope for this study is the method used, which is by using MSc Mentat software, which undergoes the finite element analysis, FEA. The second scope is the parameter, which involves the electrode force, electrode contact surface, diameter, squeeze time, weld time, hold time, and the weld current. The third one is material. DP600 steel and copper electrode is being used in this simulation. The resistance spot welding process is a process of joining two metal sheets together, which is the combination of force and electric current. The clamping is used to maintain the position of two metal plates when the process is carrying out. And there are 4 cycle time, which is the squeeze time, the time between pressure and weld, the weld time, the interval of welding current flows to the circuit, which requires the 60 cycles, the holding time, which is the time that the welding current is being stopped and the electrical force is applied, and the off time, which the time between the end of the process and the squeeze time for the next cycle. So for the heat process, it is a combination of time and current, and it refers to Joule's law. For the weld nugget form, the electrode force used will affect the size of the weld nugget, and the combination of the time and current, the heat will create a melting point, which the nugget will melt and according to the temperature and time. So for the last one is the cooling process. The current will be stopped and not be applied so that the cooling process could occur. So the important parameter that is used for resistance spot welding is the electrode itself, the size, and the current. Next one is the methodology, which involves the finite element analysis by using MSc Mentat software. This section will show how the process of resistance spot welding is being done. The simulation process starts with the adding material properties table and resizing. the contact table, followed with apply initial condition and boundary condition. The next one is load cases and jobs, and analyze the simulation. And the last one, which we will gain the results. Next one is the geometry and mesh. The analysis class, which is the current, thermal, and structural. The unit is in millimeter. Add nodes at the electrode and sheet metal plate. The element is changed into the hexagon 8. And then rename the top electrode and bottom electrode. And of course, including the metal plate, the two metal plate. Subdivide, and the meshing is in use is 0.5. As you can see here, this is the dimension of the 3D modeling that consists of top plate, which have the dimension of 100 millimeter times 50 millimeter times 1 millimeter, and the top electrode that have a dimension of 15 millimeter times 16 millimeter. The tip diameter is 4 millimeter. So it have the top electrode and the bottom electrode, which is the same size, and also the top plate and the bottom plate that have also the same size. So we continue with the geometry and material properties. This is among the important section of the resistance spot welding. Next one, under the same section, import material properties table. Starting with the GEMAT Pro software, which to convert the chemical composition into mechanical properties. As you can see here in the table, this is the chemical composition of DP600, followed by SIMUFAC welding, which the function is to present the data into graph and table form. And the material properties to be considered in SIMUFAC is thermal conductivity, thermal expansion coefficient, density, and Young modulus. And the last one, into the MSc Mark Mentat, which import material properties. As you can see here, the graph is the data that been imported from GEMAT Pro SIMUFAC into MSc Mark Mentat. This is the examples. Next, plasticity of DP600 material. It is to obtain the flow curves of the DP600 material. The strain rate used is 0.01 per second, and the grain size is equals to 0.7 microns. It is important to predict the failure of the modeling when tensile is applied. This is the examples of the flow curves of DP600 materials. The perimeter of resistance spot welding are 17 cycles of weld time, 8 kiloampere of weld current, 5 kilonewton of force applied, 25 cycles of squeeze time, and 10 cycles of holding time. Contact body and interaction is divided into two, which is contact between plate and plate, contact between electrode and plate. As you can see here, the contact type is changed into glued. The show properties also being changed into electric, and the table assigned for contact body and interaction is electric contact conductance, sheet, and sheet. Initial condition and boundary condition. The temperature is set up to 25 degrees Celsius, which is the same as room temperature. The temperature will increase as the current increases. The next one is important, which selecting the right nodes for boundary conditions. If we did not select the right nodes, we will have problem with our simulation. Load cases and jobs. There are 3 stages of load cases is being applied, which is the resistance spot welding process, the cooling process, and the tensile test. The objective of load cases and jobs are to detect any errors or warnings before running the simulation in order to get the perfect results of the simulation. And the important part is, do not forget to assign the user subroutine file. This is my third section of my presentation, which is the analysis. This section will focus on the resistance spot welding weld nugget form, the temperature and heat affected zone of my study. As for the weld nugget form and heat affected zone, the diagram shows the formation of the weld nugget size. Based on theories, a good form of a weld nugget size must not be bigger than the size tip of the electrode. This is proof in the diagram that shows the weld nugget size is 4 mm and it is smaller than the size of the tip of electrode. The analysis of the temperature can be seen on the model. During the process, the highest temperature occurred at the center of the nugget. On the left side of the diagram, the gradient represents the temperature of the weld nugget, which brings that the yellow is the hottest one, while the purple is the coolest one. Based on theories, an ideal temperature for a weld nugget to form is between 1300 degrees Celsius and 1500 degrees Celsius. As for this simulation, the temperature achieved for the model is 1400 degrees Celsius. In the last section, which is the conclusion, I have listed 3 things that I think that can be concluded in this study, which is the summarization of the study, the limitation of the study, and the future improvement that can be made. Based on the simulation, the objective was achieved, which heat affected zone HAZ is occurred as the red indicator showed the damage. The next one is the structure of DP600 become more stronger when other element is added. The third one is the temperature reached 1400 degrees Celsius in order to form a weld nugget. And the last one is the current increment cycle needed to reach until 41 cycle to complete the simulation process. The limitation of the study is cannot conduct an experimental regarding the tensile strength. Next one, study the mechanical properties by findings and articles only. For the future improvement, we have to do a physical experiment to know the exact strength of our design and material by using tensile tests. I would like to say thanks to my panels and everyone who watching my presentation. If you have any other further question, you can email me or contact me through my phone number. That's all from me. Thank you.